continuing with APAB section 2.4. So we're going to do some applications here. So one of the things I want to make really clear about these rules, like the product rule and the chain rule and the quotient rule, is that you are very rarely, if ever, going to be asked expressly to use those rules. It's just part of a much larger problem, like, in all honesty. So for example, in E9 and P9 that we're about to walk through, at no point do I say the phrase chain rule, right? I mean, I said it right now, but at no point in the question does it mention the chain rule. It doesn't even mention finding f prime. A lot of the struggle in calculus is reading between the lines and understanding what the question is asking you to do, because the skills you're going to learn, differentiating, all of these different differentiation rules, making sign charts, all this other stuff that we're going to learn over the course, integration, everything we're going to learn in this course, you are rarely, if ever, asked expressly to use those skills. You are given a problem where those skills are required, and you have to be able to read from what you're asked that that's what has to be done, even though it's not expressly requested. So, in E9, we have f of x equals sine squared of 3x. We are asked to write the equation of the tangent line at x equals pi over 4. So, just like we saw in the last couple examples, the equation of a tangent line requires three things, right? Number one, it requires a point, which is usually an algebra skill, although in this case it's sort of pre-calc because of the trig. Two, you need to find the slope, which is going to be using differentiation to find the tangent slope at this exact point. And then you need to write your answer in point slope, right? So let's go ahead and do the non-calc part first. So when I go to find the point, right, to find the point, I need f of pi over 4. That's going to give me my y value. So that's going to be, it is better to rewrite this as the sine of 3 pi over 4 quantity squared, right? Because that's what this really means, right? This is sine of 3x whole quantity squared. And that's going to matter when we differentiate too, right? So now you're probably thinking, well, that's awesome. I don't remember the sine of 3 pi over 4. And this is why in my class I make you do the unit circle a lot. The sine of 3 pi over 4 is a negative root 2 over 2. So this is a negative root 2 over, positive, my bad. Sometimes my brain does dumb things. It's the y value, so it's positive. It wouldn't have mattered because I'm about to square it. But point being, and you're going to have brain fart moments like that, but you want to know what you're talking about. You want to know the unit circle, right? So, positive root 2 over 2, because sine is the y value, right? So at this spot, the y value is positive. So I'm going to end up getting that this is a 2 over 4, or a 1/2. So I now have my point. My point is pi over 4, comma 1/2. That's my x, comma y, right? I then need a slope. Well, in order to find the slope of a tangent line, I need the derivative. So this is going to require a chain rule, right? Because there is a function in my function in my function. This is actually one of those 3 levels of chains, right? There is an inside function. Oops, sorry, I used orange for inside every other time. My bad, hold on. There is an inside function, the 3x. There is a middle function, the sine of stuff, and there is an outside function, which is the squared. Sorry, I'm having marker issues. Okay, there's my outside function. So, the derivative of my outside function is going to be 2 stuff to the first power. Well, that stuff is a sine of 3x, right? The derivative of the middle function is going to be the derivative of sine, which is cosine of the stuff inside the cosine, or of the stuff inside the sine. And then the derivative of the inside is going to be a 3. I'm going to suggest that it's really not worth cleaning this thing up. You don't really care what f prime of x is, you care what f prime of pi over 4 is. So I'm going to suggest that it's a lot easier to just go ahead and plug in those pi over 4s. This is going to be a 2 times the sine of 3 pi over 4, which we just found, times the cosine of 3 pi over 4, which we didn't just find on purpose, but we kind of accidentally just found because I did something dumb. So I'm going to get that my tangent slope is going to be a 2 times a root 2 over 2 times a negative root 2 over 2 times a 3. Excuse me. So, I'm pretty sure that the root 2 times the root 2 gives me a 2. So on the top I have 2 times 2 times 3, right? Divided by 2 times 2. So, and there's a negative. So I have negative 2 times 2 times 3, which is 12, divided by 4, which is a negative 3. So now, I then have an answer, y minus the y value, which is a 1/2, equals my m, negative 3, and then in parentheses, x minus my x value. Now, again, I would not suggest cleaning this up. There's no good reason to. The most I would possibly suggest doing is adding the 1/2 to the other side if you were asked to solve for y, which most of the time you're not. So, if you want to try P9, go ahead and pause me. I'm going to walk through it. It's the same question, except you have a g of x that is the square root of x squared plus 3, and I want the tangent line at x equals negative 1. So, go ahead and pause me if you don't want me to do it. So to find my point, I'm going to go ahead and use some algebra, right? G of negative 1 is going to be the square root of a 1 plus 3, which is root 4 or 2. So my point is negative 1 comma 2. To find my slope, again, I'm not expressly asked to do a chain rule, right? But this is a chain rule because this is an x squared plus 3 to the 1/2. I have an inside function, the x squared plus 3. I have an outside function, the stuff to the 1/2. The hard part, oh, I'm sorry, guys, I didn't inch you over enough. The hard part is that you're not being asked to do the chain rule. You have to know from looking at the problem. And the only way you can do that is get lots and lots of practice, right? So my g prime is going to be the derivative of the outside, which is going to be 1/2 stuff to the negative 1/2, excuse me, times the derivative of the inside, which is the 2x. So I'm pretty sure that my g prime of x ends up looking like a 2x on top of a 2 root stuff. I'm just going to cancel the 2's. Remember, I don't really care about g prime of x. I care about g prime of negative 1. So g prime of negative 1 is going to be a negative 1 on top of this root 4. So I get negative 1/2, right? So now I have my slope, I have my point, and all I have to do is put the pieces together to get an answer. So, excuse me, y minus the y value equals my m, which is the negative 1/2, and then in parentheses x minus the x value. Again, I would not solve for y unless asked to do so, and if so, I would just add the 2 to the other side on the outside. I would not distribute or clean up in any way. I know a lot of you have been taught your whole lives to do things in slope-intercept, but the honest answer is that you can see how complicated these problems are even when you're not doing simple things like solving to put things in slope-intercept. The more little math you do, the more likely you do something dumb, like I almost forgot that this was a positive. Like you make little mistakes the more you do, and that's just a volume thing, not volume as in like physics and the quantity. Volume is in the sheer amount of math you do. The more mathing you're doing, the more likely you're going to make a mistake, and it's always on the dumbest part of a problem. It's like adding 2 and 2 and getting 7. You don't make a mistake on the crazy calc problem, but then you add wrong, and it stinks. So again, do as little math as possible to simplify, okay? We're going to do one more problem because I want to introduce you, if I haven't already, and I really don't think I have, but sometimes my brain's a little bit fried, I want to introduce you to the concept of a normal line, because that'll come up sometimes too, and it's sort of the counterpart to a tangent line, and then we'll call it a day. And this probably comes up in a different section of the book, but who knows. All right, so if you're looking at the planet Earth, right, which is round, to be clear, it is not flat. When you stand on the planet, all right, and I'm going to make you really, really giant on the planet, right? You're standing on the planet. The reason that you see that the Earth seems to be flat to you is that what you're seeing really perspective-wise is the tangent line, right? So your perspective is the tangent line to your point on the Earth. The reason that you can't see forever is because the Earth isn't actually flat. So while your eyes are doing this, the Earth drops off because, again, totally not flat. And so you're only seeing, like, to a certain extent how far you can see before the Earth drops off from the tangent line that you're looking at. In physics, there's this thing called gravity, and not just in physics, like in the world, there's gravity, okay? The reason that you don't go plummeting through to the core of the Earth is because there is a thing called the normal force. That normal force is perpendicular to your tangent line. That normal force essentially goes right to the radius of the planet, or is a radius of the planet right to the center. I know the planet's not actually a circle, so don't get on me about the small little technicalities. But the normal force is perpendicular to the tangent line, right? So the reason I mention that is that you know that the slope of a tangent line, right, is the derivative, right? So, for example, let's just pretend that I told you that the tangent slope f prime of, let's just say 1, was, I don't know, let's say 2, okay? The slope of the normal line, right, the normal line, which is the one perpendicular to the tangent at this same point, this point, for the record, is called the point of tangency. Okay, the slope of the normal line, because it is perpendicular to the tangent slope, is the opposite reciprocal. Now, that's a fancy way to say flip slope, change sign. So, my mn, which I'm going to use for normal, is going to be a negative 1/2. I flip the slope. Instead of being a 2 on top of a 1, which is what a 2 secretly is, it becomes a 1 on top of a 2, and I change the sign, hence the word opposite. Again, in my brain, when I hear opposite reciprocal, I think like a caveman and think flip slopes change sign. I don't know why I expect that a caveman would be able to do calculus, but in my brain, a caveman can do calculus, and I think flip slope change sign. I also don't know why my caveman is so able to speak. I feel like cavemen probably just grunted. Anyway, so let's do a problem with a normal line. I think the last example that we did was maybe just 10. I want to say it was 10. I don't know. It was probably 9. I don't know. My brain's fried. I think the last one we did was 9. We're going to call this one 10. This is what happens when the examples get up to 10. I can't count that high, which is sad and true, but it is what it is. All right, so I think it's example 10. This happened the last time we hit 10 in a section 2. All right, so I'm going to give you an f of x. All right, let's do... Okay, let's do x squared e to the 3x. We are gonna, we're gonna write A, the tangent line equation. I'm gonna say tan line equation because I'm lazy. And B, the normal line equation, which I'm just gonna say norm line equation. At x equals, let's just not break the bank. Let's just do 1. Okay, so we're gonna write the tangent and normal line equations at x equals 1. And you're probably going to hate this just because there's a bunch of stuff going on. It's a product, and in the product there's a chain because of the 3x, and also it's got an e, so you're probably really loving this. But let's do it. All right, so I picked a slightly hard version of this, but so here's my u, here's my v, which notice that my v is going to have a chain in it, right, because my v has a function in my function. So first thing I need to do, I don't even know why I started there. The first thing I should do is the algebra part, right? Why not do the most straightforward part of this problem? I need a point. It's 1 comma blank. The way I find that blank is by finding f of 1, which is going to be 1 squared times e to the 3, right? Which is just e to the 3rd, right? So you should leave it as e to the 3rd. That's the most accurate. In your brain, right, and this is not something that you say out loud, but if you're ever really struggling, so in your brain, if you're struggling, e is approximately 3-ish. Pi is also approximately 3-ish. You should never write that down. I mean, I know I just wrote it down and I'm breaking my own rule, but if you were stuck, like, if you're having a panic attack being like, oh my gosh, 1 comma e cubed, I don't even know what that is, it's kind of close to 1 comma 27. It's not really a 27, and if you wrote it as a 27, it would be an issue. Please don't do that. But in your brain, if you're having a panic attack about this, be like, oh, that's kind of like a 3 cubed, because it's totally kind of like a 3 cubed. The same thing with pi. E is slightly smaller than 3, so this will be slightly smaller than 27. Pi is slightly bigger than 3, so this would be like a pi cubed to be slightly bigger than 27. Again, these are internal monologue thoughts only. You don't want to share that on the AP. You don't want to write it down. But if you're trying to make sense of some numbers and you're trying to have that general number sense, it's good to know that. Okay, so I got my point. The next thing I need is a slope. In order to get my slope, I'm going to have to do this derivative. Remember, at no point did product or chain get mentioned in this problem. And in fact, at no point did the word derivative get mentioned. You have to know that in order to find the tangent line slope, you are differentiating. Nobody's going to tell you that. You have to know that. All right, so u, right? So u dv, remember my dv is going to be a chain, plus v du. So u, x squared. dv is going to be a chain, right? The inside function is the 3x, the outside is e to the stuff. So my derivative of the outside is e to the stuff times the derivative of the stuff, which would be 3, right? Plus v, which was e to the 3x. du is going to be a 2x, right? Cool. Again, I'm going to point out that this is one of those times that simplifying is just not a good plan, man. You should just go ahead and plug in 1 and find your tangent slope. So my tangent slope is going to be f prime of 1, which seems to be 1 times e cubed times 3 plus e cubed times 2 times 1, right? So I'm pretty sure that I get 3e cubed and 2e cubed, which is 5e cubed, right? Again, if you were stuck trying to ration this out or reason this out and figure out what number this is, it's about a 5 times a 27, but it's totally not a 5 times a 27. That's just like kind of what it's close to. You should leave it as that. So then, my answer for A, right, my tangent line, is going to be y minus the y value equals my m, x minus the x, oh sorry, it was a positive 1, so x minus the x value. I was thinking it was a negative 1. And you should leave it like that. If you stubbornly insist on solving for y, you should just add the e cubed over and leave it alone. See how that plus e cubed is just sitting at the edge? For B, here's the great part about these problems. When you do the normal line, you totally plagiarize your own work. You literally keep everything the same except you change the slope, right? So I'm going to say, oh, my normal line is y minus the y value equals my m, which I'll deal with in a sec, x minus the x value. The only change I'm going to make is I'm going to flip this and change the sign. Flipping it, because it was over 1 secretly, just makes it a negative 1 over the 5e cubed, okay? So that's my work, and I'm going to go ahead and do it a P10 question mark, because again, I can't remember if this was actually 10. Again, I know that this is, I keep saying this, but this is what people hate the most about classes like AP Calc or some of the AP Sciences. You're not going to be expressly asked to do a skill. If you were, it would be a lot easier. If you walked into the AP and I just said, oh, differentiate this thing using the chain rule, great, but nobody's going to say that. We're going to hand you a question and you're going to have to figure it out. So that's what's kind of tough about this. And the only way you get better at that is by a lot of practice, okay? So let me do a P10, all right, and then we'll call it a day for this video, okay? So P10, again, I question mark because I can't remember if I actually had done an E10 before this, okay? So we're going to do the same thing. We're going to do a tangent and a normal line, right? A is going to be tangent line, B is going to be normal line. Let's do g of x equals, let's do, well, let's do a 3x over an x squared plus 1 to the third. Yeah, it's not disgusting. Cool. So A is going to be tangent line. B is going to be normal line. Right? And for both of them, we're going to say at x equals negative 1. Sure. Okay. So pause me if you don't want me to keep going, because I'm going to do the problem now. So the first thing I need to do is find a point. And again, I do that first because it's the part that involves zero calculus. My point is going to be negative 1 comma blank. The way I find that y value is by doing g of negative 1. So that'll be a negative 3 on top of a 2 cubed, so I get negative 3/8. And again, it doesn't have to be pretty. Negative 3/8 is your point, and that's fine, right, is your y value, and that's fine. Now, when I go to do the slope, I'm going to need to differentiate. So my high function's just fine, but my low function is definitely going to have a chain, right? And there's not much I can do about that. It's a function inside a function. So when I go to find the slope, right, so my g prime of x is going to be low x squared plus 1 quantity cubed. D high is a 3, minus high, which is a 3x, d low, which is going to be that 3x squared plus 1 to the second times the derivative. So see how this is my d out, right? And this was the derivative of the inside, okay? Divided by this whole x squared plus 1, quantity cubed, quantity squared. So that's going to be to the 6th, right? Now, it's your call entirely how much you want to simplify this before you start. There is a huge DCF. If you want, you could take out a 3 and 2 of the x squared plus 1s, because this has 2 of them and this has 1 of them. And that's fine. I'm not against it. It's also totally okay if you're like, you know what, I'm decent with numbers and I only have to plug in a negative 1, forget it, I'm just going to plug in a negative 1. Either of those is fine. Me personally, I think that in this case, with this massive GCF, I would probably simplify. But if you just want to plug in the negative 1s and say, okay, so this is a 2 cubed times a 3, that's not wrong, right? If you wanted to just say, hey, I'm going to plug in, right, this would be a negative 1 squared, so it's a 2 cubed, right? So that's an 8 times a 3, right? Minus, this will be a 3 times a negative 1 times a 3 times a 4, because it would be 2 squared, times a negative 2, all over a 2 to the 6th, which is a 64. That's fine, and you could clean it up. If you did that, you'd get 24, and then you got to pay a lot of attention to your negatives here, right? There's 1, 2, 3 of them, so it's going to come out negative. And you're going to get 3 times 3, which is 9, times 4, which is 36, times 2, which is 72. So you're going to get 24 minus 72 all over 64, right? So you should get 48. Double check my math. Right. You should get a negative 48 over 64. Those both have 8s. Oh, they have more than that. They have 16s. So it's a negative 3 over 4, I think. right? Now, you don't have to simplify it, but there it is. Now, for me personally, I know that I'm more likely to do this stuff wrong, so I probably would have gone from here. I would have taken out a GCF of a 3 and an x squared plus 1 quantity squared. That would have left me with the other x squared plus 1. It would have left me with, we'll just assume I took out that 3. It would have left me with a minus, excuse me, a minus 6x squared, right? And on the bottom, I could have this x squared plus 1 quantity to the 6th. So I would have canceled this guy and made this guy a 4, right? And if I did that, now when I plug in, let's see if this pans out, right? You could also clean this up and make it a negative 5x squared, right, plus 1. Okay, if I did that, I would end up with a 3 times a negative 5x squared plus 1 all over this x squared plus 1 all to the 4th, right? So what seems to happen, right, that would make my tangent slope if I plug in. When I plug in a negative 1, I would end up with a 3 times a negative 5 plus 1, which is a negative 4, right, all over a 2 to the 4th, which is a 16. That's a negative 12 16ths, which is totally a negative 3/4. Sweet, we win. So, cool. So anyway, after all that work, right, I killed myself to get the slope, the tangent line slope is a negative 3/4. So I'm going to give myself a little bit of room. I have my point, I have my slope. I'm going to erase down here for the sake of my sanity. So I'm going to erase down here and write that my slope, right, after all that work, we found that my slope, my tangent slope, was negative 3/4, right? For the record, that means my normal slope is going to be a positive 4/3. So now I just have to answer my questions, right? So my answer to A is y minus the y value equals my m x minus the x value, right? If you stubbornly had to solve for y, which really, really, really you shouldn't, right? You'd subtract the 3/8 over, right? But this is by far the better answer, right? And my normal line is exactly the same answer. I plagiarized my own work. I just flip this guy and make it a positive 4/3. Right? And again, this is the better answer. If you stubbornly insisted on solving, you would just subtract the 3/8 over. But the more math you do, the more likely it is you're going to do something wrong. And you guys are going to see that when you look at my videos, because I guarantee that stuff goes wrong in my videos sometimes, because the more math you do, the more math you do wrong, no matter how good you are. It's a true story. So anyway, that's we're going to call that it for the chain rule section. And when we come back, in our next video, it'll be 2.5, which is implicit differentiation.